In this video, we're going to look at acids and bases, what they are, and how we can identify them. So acids are chemicals and they break apart in water and they release a very small particle called a hydrogen ion. And the strength of an acid depends on how easily it releases those hydrogen ions. So the stronger an acid, the more hydrogen ions are released and the faster they're released. So in addition to being able to release hydrogen ions, acids are also highly reactive. They will corrode most metals. They also conduct electricity. We don't eat strong acids, but if you have a weak acid, it will have a sour taste like lemon juice and produce a sort of tingling or stinging sensation on your tongue. Some common examples that you will have come across, a lot of them are in the kitchen. Citric acid, which you find in fruits, particularly things like lemons and oranges. Vitamin C's correct name is ascorbic acid. It's a weak acid. You can taste the sourness in some apples and things like that. Vinegar is acetic acid. Carbonic acid is what you get in fizzy drinks when carbon dioxide dissolves, and lactic acid is found in milk products that have been fermented, so things like yogurt and cheese. So we use acids in food because microbes, bacteria and fungus do not like living in acid conditions, so it means we can store food for longer. We can also use acids when we're baking because if we have a chemical like we do in self-raising flour or baking powder that releases carbon dioxide when it reacts with an acid, then you can have bread or cakes rising when they cook. However, we have to be a little bit careful because if you leave food behind in your mouth, there are bacteria that will turn that food into a weak acid, and over long periods of time, that weak acid will start to destroy your tooth enamel. So you will get tooth decay. There's also acid in your stomach. It's hydrochloric acid. It's actually a very strong acid. It's important to have it there because, as we've already discussed, microbes like bacteria don't like living in acid, so it's a way of protecting us if we happen to eat some. It also provides the right conditions for the enzymes in your stomach to work and do digestion. But we have to be careful because we don't want to damage our gentle stomach lining. So there's a mucus which is made by your stomach, which forms a barrier between the contents of the stomach and the muscles in your stomach wall. So it protects your stomach from the acid. And if your mucus lining fails, you can get stomach ulcers, which are quite painful. Now, the opposite of an acid is a base. A base accepts hydrogen ions, it kind of soaks them up from a solution or neutralizes an acid. And like with an acid, the stronger the base, the more hydrogen ions get soaked up or accepted. And the word alkali, which we use in the classroom a lot, is just a special name for a base that dissolves in water, a soluble base. And it also contains hydroxide ions, which help to neutralize acids. Oh, missed out. Examples of common bases, you will have met them again, probably in the house, but probably not in the kitchen cupboards for eating, but in the kitchen cupboards for cleaning. So common bases include soaps, detergents, oven cleaners. Strong bases are things like drain unblockers. A weak base would be something like baking soda that you put into cooking. You might find them in the medicine cupboard because an antacid, like an indigestion tablet, neutralizes the effects of an overly acidic stomach. So, safety. We need to be very careful because bases and acids are similarly damaging to our skin. They will corrode our skin, they would damage our eyes, and they would stain and destroy our clothes if we didn't protect them. But we need to have some kind of measure of acids and bases, and for that we use a pH scale. And the pH scale is actually measuring the amount of hydrogen ions or hydroxide ions in a solution. So in the center, it is neutral. So pH 7 is neutral. That means it is neither basic nor acidic. and pure water would be pH 7. Anything less than pH 7 is an acid, and if it's close to pH 7, it's a weak acid, and if it's far away from pH 7, then it is a strong acid. Over this side we have alkalines or bases, so close to pH 7 but above pH 7 would be a weak alkali or a weak base, and far away from pH 7 would be a strong alkali or a strong base. So annotate your diagram with these words. And finally, we've got this pH scale, but how can we visualize the pH scale? We can use an indicator. Indicators are chemicals that change color at different pHs, and there are lots of different types that you will meet in the school laboratory and in cooking. So universal indicator actually has a whole range of colors which cover the whole pH scale from red all the way down to, for a very strong acid, all the way up to pH 14 over here, a very strong base with lots of colours in between. Litmus here just has two colours, red or blue. So if something is acidic, it will go red. If something is alkaline, it will turn the litmus paper blue. Phenolphthalein is either pink or clear, and red cabbage, a natural indicator, again has a range of colours. They are slightly different from the range of colours you get with universal indicator, but they still allow us to see many different levels of acid and base.